introduce you, or will you introduce yourself?
We can introduce ourselves.
Okay. Sorry, me or you?
We can do it ourselves.
Okay. Right.
This is the microphone that's supposed to speak.
Yeah. They have a couple of antennas on the access point up there. It's like 6 of them.
He also told me the slides should be 43. I just changed it to 60 to 9 because they are. Yeah. It's fine.
We ready? This is a talk on reproducible builds, on building software everywhere, not just RPMs, but all sorts of software, and in bit for bit. I'm Dennis Gilmore, and this is Holger. A little bit about me. Most of you probably know who I am, so I'm not going to drone on too much, but I'm Dennis Gilmore. I have been a Fedora user since day one. I used Red Hat Linux before that. I've been involved in Fedora since Fedora.us, that was building extra packages, Red Hat Linux. I'm currently the platform team lead at Red Hat, so I look after release engineering for RHEL and Fedora. And that's been my day job for the last 8 years is Fedora. I help make sure we get the bits out there and built and the sanity and whatnot of them. And here's Holger, he'll introduce himself.
I'm Holger Levsen. I work on Debian. I will spare you the Debian details. Mostly I've used Fedora in 2008 or something for OLPC to build the school server there. And I've been working on reproducible builds for the last 2.5 years now. I'm funded by the Linux Foundation to work on this as well. And the Debian branding of the slides is my fault, not Dennis. This talk is mostly explaining what the Debian story about this, and then in the end we'll have some outlook what to do for Fedora. So, and this talk is not my work, but I'm just one person of a huge crowd of Debian people who worked on this. So, first before we start, who are you? So who has seen a talk about reproducible builds here? Some people. Nice. Who has contributed? Yay. Who uses Debian? Yay. Maybe this question, who uses Fedora at Red, should have been... So you're all awake, that's good. So first a bit about the motivation of why we do this. So free software is great, you can share it, study it, modify it, use it, that's really cool. But we can do this with source code and we use binaries. And we need to believe that the binaries come from the source they are said to come from. There's no way to programmatically, automatically find out that this binary comes from a given source. You can maybe analyze this for one small binary, but it's manual work, so it's generally not possible. And I don't want to believe. I want to be sure, I want to know stuff. And this is what it's about. And the problems causing this is explained in very much detail in this talk from 2 years ago at the 31st Chaos Communication Congress from Mike Perry and Zed Schön. I'll give some examples what they tell there in an hour or something. So that one example of a root exploit in SSHD, and there was a single bit in the binary difference, and if this bit was different, it was greater equal or greater, and that's a 1-bit binary and 500 kilobytes of binary. that's a root exploit. And so if you change one bit in a binary, you might get root. And they also had a live demo with a kernel module which modifies the source code in memory. So if you look at the source code is fine. If the compiler builds it, you get a backdoor. Yeah. And you cannot really be sure what's running on your machine, or when you can, you install it, and then it's probably a good system. But after it's been on the network for some time, you cannot really be sure, especially if the motivation is high. And it's also Fedora has a build network, Debian 2. Debian developers can do binary uploads still. But even if everything is built on the build network, this build network is a great target. And it's not paying your admins, it's paying your janitors, paying whoever is involved there. And if you really have motivation and money, you can compromise these systems. And there's also legal challenges. You could be forced to put in a backdoor in your system, maybe just for some customers, and get a gag order, and you're not allowed to talk about it. So this is what we are trying to prevent. And another example was also the CIA conference that was in the Snowden paper. They had the idea to backdoor SDKs to compromise the users by going after the developers. And while this was a CIA white paper, there was Xcode Ghost, which was something found in the wild, which was a Trojan SDK for iOS, which was put on faster servers, which people in China mostly use when they wanted to build iOS application. They downloaded the SDK from another server, which was faster, but which was compromised. So there were 20 million applications which were backdoors with good source code, but bad binaries. So this is happening. It's not fantasy. And our solution is that we think that anybody should be able to independently verify that a given binary is coming from the source. So you should all be able to verify the same thing. And we call this reproducible builds. It's not about repeatable builds, but reproducible builds in the sense of bit by bit identical. So you build a package 5 times, and you get 5 times the same checksum, and not a different checksum. And also if you do it in 2 weeks or 2 years, get the same checksum. And that's really it. That's all it's about, to get bit by bit identical binaries. And the same with RPM, whether it's Debian packages or RPM, it's the same. For RPM, there's a bit the challenge that there's the signature in the RPM, so you cannot just recreate the signature, you need to replay the signature, but that's doable. Because if you create the same binary contents, the same signature will always apply, and you can get bit by bit identical container as well. So what we want is that we really just do the checksum on the result, and the checksum should always be the same. We don't want to analyze the contents, because if you have tools which analyze the contents, these tools can be buggy, these tools can be exploited, so there should be no special tool to ignore some differences. We want really the whole thing to be the same. And we think this should become the norm. And when I put this there, we want to change the meaning of free software. It's only free software when it's reproducible. And I gave this talk at the Free Software Foundation last year. I was a bit curious what they were thinking. And in fact, they liked it, and they put, now the Free Software Foundation has a priority list of important software projects. And as part of their security priority, they put reproducible builds there 2 weeks ago or something. So this is, the Free Software Foundation basically agrees. And there's more than just security. There's lots of QA benefit. We found many, many subtle bugs. Like we build twice and then verify the results. Like we had one example, we had the Python shebang line changed. Because if you build it on a fast machine below a second, then the make timestamps were the same. So if you build it on a fast and a slow machine, you would get different results. And we found many, many QA issues like that. So if you try to make your software reproducible, you find a lot of other stuff which is strange and funny. Google does reproducible builds to save time, developer time, and thus money. And Google made all their internal software reproducible. There's smaller deltas, so you get faster updates, both for packages, but also for images, because the content changes less, and so you can just reuse the data. And as a side effect, you can also do a meaningful binary diff between two versions. Because if you just change one function of a huge program, then only this small part of the program should change. And if there's lots of other differences from timestamps and whatever, you cannot see this. But if everything stays the same, you should be able to see just this function has changed. And there's probably more, but these are the main other benefits. So what we've done now, since a year, we have this website, reproduciblebuilds.org, which is, we started with having information in the Debian wiki, but at some time we wanted to have more distribution agnostic information. So this, if you take one URL from this talk, then please take this URL with you. There's documentation there which has common mistake or common problems, pitfalls with making stuff reproducible. Yeah. We have IRC channels. With one for Debian and one general one. We have mailing lists. And we wrote Diffoscope. Diffoscope examines differences in depth. So it recursively unpacks an archive or an ISO or whatever, and recursively goes through everything and will display that. So you have whatever RPM, which has a PDF inside, and the PDF has an image, and the image, the timestamps vary, then Diffoscope will show you the difference. There's HTML and text output, and it's available in Debian, it's in Fedora, it's on FreeBSD, it's quite widespread use now. And this is how Diffoscope HTML output looks, and the easiest to see is the lower line there with this version, which is different in this example. But it will also, in the beginning, Diffoscope only worked on 2 Debian archives, but now it also works on ISOs, you can put it on directories. You can also use it to compare 2 different versions. Just try Diffoscope, it's really, really useful. And if you want, but Diffoscope is not the tool to really see whether something is the same. Diffoscope is for debugging. If you want to compare if something is the same, it should be really the same checksum. Diffoscope is just for finding the reasons why something is not reproducible. And there's also a web service, try.diffoscope.org, where you can upload 2 files so you don't have to install Diffoscope. If you install Diffoscope and install all the recommends, it will install on a base system about 1.5 gigabytes of binaries, because it can also go APKs, Android APKs, it can do whatever tools, so all the different helper tools make it huge, quite big. And then I started to set up test reproducible builds.org, which in the beginning was just called Reproducible Debian.net. In the beginning, we only tested Debian by just building a package twice and compare. And then we started to add more variations, that we changed the username, changed the time zone, changed whatever parameters. And now we're also not only testing, we test all 3 Debian suites there constantly on 4 architectures. And we also test OpenWRT, NetBSD, FreeBSD. We used to have tests for Arch Linux and Fedora, which are at the moment not working. And it's a giant Jenkins setup with 44 nodes and terabyte of RAM. So it builds Debian twice in 2 to 4 weeks, constantly. And it's also now, there's many people working on this setup. So this is how we vary the build, and this varying the build is done to try to catch variation. There will be more variations in the wild, but we assume if we just vary this, we will find most likely cases. So we vary the host name, the domain name, the time zone, the locales, the user. We built with different kernel versions. On i386 we built with a 64-bit kernel and a 32-bit kernel. We have some architectures where we have different CPU types. The file system order is also important because here the order is not deterministic or depends on the inodes, which can change. And we also have systems running in the future. So we have systems running a year and a month and a few days in the future, so we can see what breaks, which is also funny because we'll also find bugs where certificates expire. And if you want to reproduce something in 2 years, then that's bad. So maybe we should also not just build 1 year in the future, but 5 years in the future. But then we'll catch more errors and we want to find less errors. So what we found, mostly it's timestamps. Timestamps are either the file timestamps, or also very common is that the timestamp is outputted in the build product, not so much in the program, but more in documentation. So the man pages are often included. This was built on this date, which is really meaningless if you can rebuild on every day, any day, and get the same. And also the time zone. If you unpack a zip archive from 20 years ago, the local time zone will be applied. And that goes on the build product again. The locales are also in there, the build path, and everything else is some other corner cases, but it's mostly these 4 things which makes stuff unreproducible. And it's also sorting order is different depending on the locale. Not for the alphabet, but for the special characters, and then you get this. Hashes, if you don't sort hashes, then you also get in arrays, they have random order. And it's often easy to use, you call gzip -n to have timestamps in UGC or whatever. This is all on this documentation part of our webpage now. Besides this documentation part on the webpage, there's also Luna gave a talk at the CCC camp 2 years ago, where he had many examples with problems and the solution. So if you want to watch the video, this is another good video to watch. And then we came up with source date epoch, because the build date is usually not meaningful. And so source date epoch is the last modification of the source code as an epoch, so in seconds. And this can be used instead of the current date. It can be used in random seeds, so they become pseudo-random. In Debian, we set this from the latest Debian changelog entry. Could also be the last git commit or whatever. And we wrote a spec which is 2 or 3 kilobytes of ASCII text, so it's really short. You can read it in 3 minutes, or 5, whatever. It has been adopted by many distributions and tools like this. There's patches for RPM, deep package support, the GCC, GoScript, whatever. It's more than 50 tools now which support source date epoch. So if source date epoch is not set, these tools use the current time and date, and if it's set, they will use that. And then we wrote 2 more tools. Stripped non-determinism does that. So it removes timestamps from images or other timestamps which are clearly meaningless. They are just set to 0. And in the Debian build case, we call it with step helper. So all packages which use step helper, which are 90%, use it automatically. Stripped non-determinism is not used by other distros yet, but it will increase the percentage of stuff which is reproducible. And the other tool which we started to write in the last half year is the reprotest, which builds something, then applies variation, and then builds it again. So what we do on this big Jenkins setup, this is also something for you to use, so you can build something with reprotest and see whether it's the same. I'm not sure if anybody has tried it with building RPMs yet. So in Debian, the status in Debian, this is testing, and testing is now 93.3% reproducible, which I think is fairly great. We were getting further slower, but on the other hand, 3 months ago we were still at 91%, so there is still progress happening. And then we had the idea, we don't vary enough, so for unstable, we started to vary the build path. For testing, we still use a deterministic build path, which is basically /build_source/version. And there we use a built-in random path, and the build path gets embedded in lots of stuff, so we only get 78% reproducibility there. So what we think we will do for stretch, or for currently we say use a deterministic build path, but we want to be able to build in any path, because that developers will do the same. And I want to compare if I build in home Holger and he builds in home Dennis, then I also want to compare this. But this might take some time. We have patches for GCC, but GCC is GCC is only used for half the archive or something. And then there's also lots of stuff in documentation generators. So at the moment, we still recommend to not vary the build path and just say use some standard path. And then, because just looking at those 25,000 Debian packages is too much to grasp, we have package sets as well. So we have a GNOME package set, a base set, or the Perl packages, or the Ruby packages, or the whatever packages. And so Debian, the build, the essential set, which is 20 source packages or 30, is now reproducible except Bash and GCC 6, I think, and GCC is the documentation. So the other package sets are not that reproducible yet, but that helps to look at people. And we categorize issues, so we have a system to take notes, and we found 282 different issues. So it's Erlang embeds the build path, and Pandoc puts something in there, or local variation. These are all these different issues. Issues. And we found 7,000 packages still which have some kind of issues, even though they are not, we have better review. And we've looked at almost all packages, so there's like 100-something packages left where we don't have a node, or we don't have an ID. And we want also make these node cross-distro, because if something is, most likely the issues are the same on Fedora and FreeBSD even, because it's all the same upstream software. And then to rebuild, we came up with build info files, which collect the source code users with their checksum, the generated binaries, which is the stuff you want to reproduce, and the environment. And later can be used to recreate the same environment, because you need to have the same versions installed. Else you cannot guarantee that you get the same results. And for Debian, it's quite easy, because all the old versions are available on snapshot.debian.net. I have no idea how to get old Fedora versions, especially during development. But
it's all in Koji.
It's all in Koji.
In 30 terabytes a disk.
Oh, yeah, that's the same size as Debian. And this is the green ones are the fixed bugs, and the red ones are the open bugs. Those are all bugs with reproducible issues, and we only file bugs with patches, because else it's useless to just say the package is unreproducible, please fix. Is not a meaningful bug report. So all these 800, there's 700, I think, bugs we have left open where we have patches to make software reproducible, and most likely you can take them. And while we did this, we rely on the Debian maintainers to send these bugs upstream, which some maintainers do and some maintainers don't. So now Bernhard Wiedemann from OpenSUSE started another project where he's actively sending patches upstream. I think so far he has sent 100 patches upstream, but he started that mid-December last year, so that's not a long time ago. And at the moment, this was a proof of concept until very recently, like our changes to dpackage, the central packaging tool, were only accepted in Debian in November. So since November, dpackage in Debian unstable can create reproducible packages, and since December it stores only the build info files. So when Debian stretch will be frozen in 9 days, and we will not have many reproducible packages in there, because Debian doesn't Debian doesn't do rebuilds. So at the end of the freeze cycle, Debian doesn't rebuild everything for historical reasons. I think it's crap. But that's why Debian stretch will not reproducible, not the 90%. On the other hand, if somebody else takes Debian stretch, they will get the 90%. But Debian doesn't have it. I'm not so happy about that. And we also don't distribute the build info files yet. We saved them, but we don't have a mechanism to move them. And this is also quite unclear still how to do that. But yeah, Canonical can take stretch now or whatever, the unstable, and make either 1704 or 17010 partly reproducible. So Debian 10 in 2019 will be partly reproducible. Yay. And for Debian 11 in 2021, or whatever it is, will be, I think we should have policy mandate, if it's not reproducible, then it will not be released. But it's a long way there. And since basically at the beginning we realized it's not enough to only care about Debian, but these changes needs to go into upstream. So we started to write reports, weekly report, which is a blog, where we document our progress and development and discussions and stuff. And we made now 2 summits, one in December 2015 and one in 2016. 2016, Dennis joined us there, and Bernhard Wiedemann from SUSE was also there. There were now there were 25 projects. 2015 there were 20 projects or so. And we will do another summit this year. If you want to go there, please talk to me. We would be happy to have more Fedora people there. It's sponsored by the Linux Foundation and Google mostly, so please talk to me if you want to go there. We also did we're doing this 3rd round of outreachy now. We did 2 Google Summer of Code rounds and 3 outreachy rounds, which also brought new contributors, which was really good. So now for the stuff which probably interests you more. So these we also test now with variations on this Jenkins, on this Debian Jenkins we built now FreeBSD and NetBSD and all the other stuff. Coreboot is what used to be called Linux BIOS before. Coreboot is 100% reproducible with the CBIOS payload. The problem with Coreboot is they don't do releases at all, so they are reproducible in theory. Net and FreeBSD is almost also in the 70-80% range. It's usually the base system which is more problematic. The packages are basically the same. And there's more. And until last week, I thought that Bitcoin were the first. Because the Bitcoin developers, they were in 2011, Bitcoin had a market capitalization from $4 billion. And they thought if there's a compromised Bitcoin binary which steals the Bitcoin and put it somewhere else, the developers could not prove that they didn't make it. So they made reproducible builds so they could be sure, yeah, the binary you're running is really coming from the source code. And Tor did then the same with the Tor browser, which is the Firefox, as you probably know. So there it was clear, okay, you can also do it with really big binaries. And that motivated when Debian started in 2014. And last week I learned that Cygnus, this company which made GCC and other stuff in the 90s, they had a bit-by-bit binary, bit-by-bit identical releases in 1992 for 8 architectures. But that code bit-rotted. So, and now it's completely forgotten, and when I read this last week, I was like, wow. ElectroBSD had a talk last year at FOSDEM, where they made ElectroBSD as a small FreeBSD variant with a small base system, and that was 100% reproducible, which was the first first distro. Tails is working on their image. I think they made good. They're almost there. Web Converter is another live distro, where the images are 100% reproducible. Google Bazel is the Google build tool, which aims for reproducible builds. Doable is a build tool for Windows, so you can create reproducible Windows binaries. And there's few commercial proprietary software which is reproducible. Guess which? Windows, there's at least source code. For iOS, there's not even source code. So Microsoft sells their source code. So medical devices in your body, arms, drones, whatever, nuclear power plants, self-driving cars, they are all not reproducible. Gambling machines are reproducible. By law, for tax reasons, in Germany and France. So Bernard started with this, or started in December to build SUSE twice in this open SUSE build system. And he built 3,000 packages now and managed to get 2,000 of them bit by bit identical and 1,000 not. And I set this up with Fedora 23, so it was in 2015. But there I didn't have a patched RPM, so there was no result, and that bit rotted as well.
So for the basics in Fedora, Diffoscope's available. There's a new release of it yesterday, so we don't have the latest in Rawhide and Fedora 25 and 24. We have the previous version, so you can test your binaries today to see what the differences are between builds, which is useful. We have a few issues potentially in recording all the build info kind of data. Yum and DNF do different things. So if you create a build root with Yum, I create it with DNF. We've potentially got some problems because they resolve different dependencies, which may result in different binary. Hopefully not, but it's a area that could cause problems. There's in RPM 4.13, they added a macro to set the build host name, so you can define the build host is Fedora, and then every build will have Fedora as the build host instead of whatever the host actually was that you build it on, in order to try and make the whole lot bit by bit reproducible. And we get a few issues with signed RPM. So Koji itself strips the RPM header out and has an unsigned header. When we sign it, we strip the signed header out, and we tell Koji, write the signed RPM, and it gets the payload and shoves the correct header in there. So in theory, we could reuse that so that you could take the binary RPM that you want to reproduce, strip the header off, the signed header, reproduce the build, shove the signed header in, and it should be bit by bit reproducible. It's probably a bit ugly, and I'm getting dirty looks back there from RPM folks. But it should work. It's a bit of theory, but we also have issues where, like in the Debian case, they're looking at adding the checksums of the RPMs that went into the build environment. In Koji, we use unsigned RPMs in all the build roots. if you're using mock at home, you're going to get signed RPMs of all of the RPMs going into the build routes. So it's going to make, that may be something we just say, we're not putting checksums in there because, you can go from signed to unsigned. Contents is exactly the same sans the signature header, and, the build is reproducible or not. And then, yes, sir?
Can't you just strip the signature before you checksum?
We could potentially, strip the signature before we checksum, but it depends on where we fit it all in as well, and the cost of stripping that out and getting it all, getting all that information. We certainly don't want anything that we're going to do in Fedora. We don't want to have it be overly burdensome or too intensive, where the cost of enabling people to reproduce our builds is so high that people are going to want to turn it off because it adds 5-10 minutes to their builds. People complain already that the init of a chroot takes too long, and they want to do things so that we can make the chroots appear faster so they can get their build 2 minutes earlier. So if we add something that's time consuming, it is not going to help at all. But so that's kind of the basic part. There's a whole bunch of to-do type things. The equivalent of the build info file, we have probably 80% of the data, 90% of the data in Koji already. It's just not easy to get. We store all, for a long time we've said, we do things the way we do so that we can reproduce the builds. We've not actually in practice done that. We've not, no one's ever actually sat down and said, okay, well, I want to reproduce this, build in Koji. They're just like, oh, we've got the stuff, we can reproduce it. So it's kind of, looking at it, it's really just going from the theory of reproducibility to practically being able to reproduce stuff and say, hey, you know what, you can trust that Fedora is what we want because here's the information that you need in order to reproduce the builds. The format of how we present that information to the users is needs to be decided on. I think that there's probably two aspects that two places where we want to do it. We don't want to have people that want to reproduce set up Koji, but it's going to be really nice and convenient that since Koji has all the information, that we have an API call and we say, I'm rebuilding foo 1.1-1, give me the build info. And you can get that information in so I think mock needs to have the ability to write out a log file or write out a file that has all of the same information that you would get from a Koji call to get the build info. And I say mock and not RPM build because in the case of, say, if you're building a rel 5 RPM like for Apple in Koji today, the chroot is set up by the build host, which in the Fedora case is Fedora 25. So you're setting up a rel 5 chroot on Fedora 25, and rel 5's RPM cannot read Fedora 25's RPM databases. So if you wanted to do RPM minus QA in the build, it's going to blow up and choke, and you're not going to get builds. So I think mock needs to use the system's RPM to be able to tell you, which it does already in the root.log, but put it in the right format.
Mock's doing it. It just use the library. It's directing the installation. It should be able to
right.
Without reading the RPM.
Right. It should be able to do it in other ways, but at the very if you wanted to make RPM do it, you'd have to read the RPM database to query these were the RPMs installed in the chroot, which in many cases you can't do. There's a reason why we ban any call to RPM inside of the build root in the packaging guidelines, and it's not because we want to be jerks or anything. It's that we can't guarantee that you can do it. It'll work sometimes, and other times it won't. There's some defines that need to be set in the environment, like source state epoch. The SUSE guys told me yesterday they're working on a patch that will set a macro to get from the RPM changelog and set the source state epoch, and they're telling me they're going to send it upstream. So, hopefully that should come with time. We already record the sources, we already record the output, we know what RPMs we get from the build. So we have most of the data, we just need to put it together in a format that's consumable, which will then allow us to write some tools where we can wrap around mock and say, hey, we're going to reproduce this build. It sets up the true, it sets up the build environment, builds everything, and hopefully gets the reproducible builds out at the end. We've probably got 90% of what we need with Koji without any thought or effort, and the last piece is going to take some work and people to work on it, but I think it's something that's reasonably doable in the next 12 to 18 months. The hardest bit would be setting up something either using like test.reproduciblebuild.org or getting Google or NASA or whoever to actually reproduce builds and provide us with, or even set up something ourselves where we can reproduce the builds, but then do you trust us to provide the verification of ourselves? But yeah, it's something that I think is really reasonably doable with reasonably minimal effort, and because we're doing most of what's needed already. But so Debian uses SUSE uses Zipper in the. I looked at the equivalent of mock, and they use about a 1,400 line bash script and Zipper to do the equivalent of what we do in mock. So I'm not sure how, like in that portion, I'm not sure if there's going to be a lot of overlap between like SUSE and us in Fedora. But.
Yeah. So far this was mostly about making reproducible builds possible at all, enabling us to do this. But for the future, we need first constantly testing this, whether if that bit rots or not, or some new code is added which is not doing so. And then we still need tools, infrastructure, and policy for this become meaningful for users. So we need these build info files, we need infrastructure to distribute them, because there will be, Debian has 25,000 source packages, so 10 architectures, so that's probably 100,000 files for one release. And how to distribute that, and we want to sign these. And there's almost no work been done yet. So far we've only been focusing on making reproducible builds possible. And maybe there's very probably different projects, different solutions. Mm-hmm. So far in the reproducible builds, making it possible that it's the same source code and we can share the work, but how we build these tools that will be not so shareable. And we need something like build info files everywhere. We have them for Debian, we have some for Coreboot and OpenWRT, and Fedora, Dennis just explained how to do that. But this is all. For all the other projects, this has not really been done. And then this having individuals doing the rebuilds, we don't think that would scale. So maybe large organizations like ACLU, Greenpeace, NASA, the NSA, the Russian army, the North Korean army, the US army, if they all rebuild and agree, or we do Fedora rebuilds Debian and Debian rebuilds NetBSD, or big customers rebuild it themselves. There could be several different models, and it's also, you need to decide whom you trust and what you do if you get one checksum which is not matching. And this is all future work for the next years to come. And then we need integration in user tools. Do you really want to install this unreproducible software? Or do you want to build it yourself first and then compare the checksum? And how many signed checksums do you need to call a package reproducible? And from whom?
Isn't that what NixOS is doing all the time?
Kind of.
There's Geeks has a Geeks challenge which is a tool to rebuild and do this stuff. Yeah.
And once you get the RPMs and packages reproducible, you then can also look at things like live CDs, the Anaconda installers, and cloud images, and all the other binary artifacts that we deliver. There's at the summit. There's a couple of people that were working on a lot of the live CD stuff, like MixSquashFS. Apparently, does things that make you can't you could install everything exactly the same way, and you won't get a reproducible ISO out of it because it does stuff differently. And so they're working on fixing that so that we can, once we've got the base done, there's places under higher up in the stack that can be made reproducible also.
Once you create images with file systems, the file systems need to be reproducible, and they all put timestamps in there. The SquashFS was recently fixed, but there are other file systems which are not fixed yet. So, if you want to get involved as a software developer, please stop using build dates. If you really have to, use source date epoch. And you can also look at your distribution, like build Fedora twice, build the packages you maintain twice, just build them half an hour later or 2 minutes later and see whether they are bit by bit identically. We have lots of documentation. I'll be here for the next 2 days, as Dennis as well. You can also talk to us. Yeah. That's it.
Questions?
Maybe somehow detect automatically these kind of programs, reproducible programs, let's say, like dates, for example.
There is for Reprotest. Reprotest is our builder tool for developers, and so there's the idea, like bit like bisecting. So if you build it twice with all variations, and it's the same, okay, then it's good. But if it varies, then you stop varying the whatever the locale. If it's then reproducible, you know it was the locale. But that would mean that you might maybe need to build the software 10 times, and maybe you still don't find the reason, but that should help.
So I had a question or other remark about the future work. You were saying user interface things like unreproducible. We all know from the HTTPS certificate drama that we don't want to ask is our user, right? We just want to set some same defaults and then you say, sorry, there's something wrong with the package, I cannot install it at this time or whatever.
But potentially, it's kind of like a DNF plugin that could do something, and it could be that there's a system-wide policy that says, by default, we set it that reproducible software can't be installed, and it's something we shove in the metadata that's already too big, and,
I think that
what I'm trying to say is that for the future work, we really need to think about UI of these things, and preferably not having UI actually.
I totally agree. We need to think about this more. These are all old thoughts, and we've not spent much any time on user tools in the last year. So.
You're putting that dates in the source and then using that to build and have some artifact kind of date. What is the other biggest thing that others do that makes the build not reproducible?
Build parse. So what is the other biggest? What is the other biggest things besides build dates, which makes builds unreproducible? And that is build parse. So for build parse, we can use an easy workaround. Just use a deterministic build parse. So then I think the next biggest is probably local time zones, and which again you can fix easily by forcing time zone to UTC before the build. This is from Debian. We want to allow developers to build in their environment as it is. The other thing is also the locales indeed. We want developers to get error messages in French or German or whatever, and not force them to English.
Salt especially.
Yeah. So this. You can, if you normalize the build environment, you can get many things done. And Koji is a tool to normalize the build environment. Debian has also these tools, but in Debian they are less strict. But if you're really strictly enforcing the build environment, you get a lot of things.
How many problems do you get from different file systems?
We only looked at packages so far, so we have only very few packages which include a file system.
No, I mean,
The-
if you build it on one file system type.
Yeah.
The question was, what are the difference? What differences do you get by using different file systems like XFS or ext3, exe4? You can get quite a lot if they the sorting of the file systems is different, or depending on how they list things out and do things.
We case by case. It's mostly it's sorting issues, because the read year order is different. And we wrote another tool which I didn't mention, which is called DisorderFS, which is doing that. It's a fuse file system which randomizes the read year order, and there with the test framework we catch those cases.
Okay. Do you plan to update, let's say, packaging guidelines for new packages which will come to the Fedora regarding this issue?
At some point, the question was, do we plan to update the packaging guidelines to include something for reproducible builds? Probably at some point. I know that, so the patch that the SUSE guys were working on for RPM was to set a macro called source date epoch from changelog, and the idea is that it gets the last changelog entry and whatever time that was, which we only use dates, but whatever time that was, it would set to 0000 for the actual time of that. And if we're going to do something in Fedora, we would probably put in Fedora release and set that macro. It's set globally then, and anyone doing a build, it would just kind of get turned on. But we would probably need to. We would need documentation on if you get failures, you get issues. This is how you debug it and work on fixing the issues. But I don't know that there's necessarily anything specific we need to set. Like having packages set the macro in every spec file is not going to work. It needs to be set somewhere globally.
Yeah, that's one of the things I really liked about the reproducible build approach is that it's not so much about packaging, it's not so much about helping packagers get their work done, right? So that the packages
Right.
can be built. It's getting changes upstream as far as possible so that the tools that produce artifacts produce them reproducibly.
Yeah.
So DCC gets changed, build utils gets changed, tar gets changed if necessary. It's not about fixing dead end rules files or spec files everywhere. It's about
Right.
getting the whole ecosystem to build reproducibly. That way you don't need to change anything in a package unless you want to do it temporarily until you get the patch upstream.
Yeah.
So it doesn't really go along with guidelines in the end.
Yeah.
Yeah. There are things to avoid, but you probably wouldn't. Yeah. So I guess that's, yeah.
He said that it's not about changing the packages, but rather changing the tool change upstreams, so that we don't need so many guidelines.
Yeah.
Which, yeah.
We've got the last question, so.
And one thing what we did in Nebinus, first we changed the policy to say, we have not even said at the moment there's nothing in policy. So what the first change we want to have, it should be reproducible, and then later must be reproducible. So it's a long process. Last question.
How do you deal with build systems that are not GCC based? Like I think Cargo for Rust generates UI users something when it builds something. So every time you build, you get different stuff.
How we deal with build systems other than GCC, the same way as with GCC. We try to find the cause and send the patch upstream.
Yeah.
And there's probably Rust
So,
issues.
an example of where things went wonky there, the build hardware builders in Fedora use, the build hardware have, I think, 16 cores and like 64 gig of RAM. And the build VMs have got 4 cores and like 8 gig of RAM or 16 gig of RAM, something like that. But GHC would, when it was built on the build VMs, would get 1 hash. It was consistent, but you got 1 hash. And if you built them on the build hardwares, they got a completely different hash that it used in the shared objects. And so then you'd have to rebuild everything else because it was like this difference that was introduced into the into the package purely based on what machine you built it on and how many cores it had and how fast it could do certain things caused it to give differences in the build result. That's something we've seen in Fedora. So thank you very much, everyone.
the resolution.
Or records. So
I understood.
okay, that's fine. Thank you.
Question maybe for Holger, but so I do a lot of community builds with Gluster and related software.
Yep.
And so I've already tripping over the daytime stuff on Scratch and Fedora 26.
Yep.
Let's move away here to the next
I
slide.
do a lot of building in Launchpad.
You can build Debian packages and use it as a command system. How well that would work for there has been some people that have been looking at this student a couple years ago was looking at when Debian supported Trojan.
Well, I
You
checked
can
my
set up
calendar.
Debian
It's
building
email. It's on my
Oh, yeah. So
but
I don't think I accepted it on my calendar.
as far as